in this module from the chapter, some application of trigonometry. Let's do a sum based on angle of depression. And it's going to be a beautiful sum, a very interesting one. Let's see the sum. It says from an aeroplane vertically above a straight horizontal road. So there's a straight horizontal road, an aeroplane. The angles of depression of two consecutive milestones on opposite side of the aeroplane are observed to be alpha and beta. Show that the height in miles of aeroplane above the road is given by tan alpha into tan beta upon tan alpha plus tan beta. So now let's understand what we are supposed to do in the sum, how we are supposed to draw this particular concept. Let's understand, it's very important. Now it says from an aeroplane vertically above a straight horizontal road. So there's a straight horizontal road and there's a aeroplane vertically above there. So there's a plane. See, you have an aeroplane coming in, right? Beautiful. Now what it says is the angles of depression of two consecutive milestones. So there are two consecutive milestones. So we can observe there's a milestone there and there's a milestone here. Observe, right? Beautiful. So two milestones. So for our reference, we have just numbered one as 10, the other one is 11. So the difference between them, since they are consecutive ones, the difference between them would be 1 mile. Yes, that is what we have to understand in this particular sum. The difference between these two would be 1 mile. Easy, this you understood, right? And they are on opposite sides of the aeroplane, right? If you observe, aeroplane is there, one is on this side, the other one is on the other side, right? Now this is what we had to draw till now. And they say the angles of, what we are seeing is angles of depression. There are two angles of depression formed. One when the aeroplane, from the observer from the aeroplane is observing one milestone, he is making an angle. And one when he is observing the other milestone. So when he is observing this, the observer is there, so that's a horizontal line. And this is a line of sight. The angle which is made here, that angle of depression is given as alpha. The same way there is an angle of depression formed for the next one. So for the next one we have that. So again we will have an horizontal there and a line of sight here. So the angle which is made here is nothing but beta, right? This is clear. They say that show that the height in miles of the aeroplane above the road. That means the height of the aeroplane from the road. That means we are talking about this perpendicular distance, right? We have to show that this height, let's denote it by h. To denote that this height, that is h, is equal to tan alpha into tan beta upon tan alpha plus tan beta. This is what you're supposed to prove in the sum. Now let's understand how we're going to solve this further. It's going to be very easy, right? First of all, let's get those angles into the triangle now. So observe very carefully. Now if you look at this, observe that angle EPA and angle PAQ. What type of angles are they? Yes, they are nothing but they are alternate angles. What can you say about them? You know that these angles are going to be equal, right? Why? Because we know that the lines are parallel, so alternate angles will be equal. So we got the angle PAQ as alpha. The same way if you look at the next one, yes, if you observe angle FPB and angle PBQ, what type of angles are they? Yes, it's nothing but it's again a pair of alternate angles. What can you say about these angles? We know that these two angles are nothing but they are equal because we know that the lines are parallel. So therefore the alternate angles are equal. So this angle happens to be beta. So this is what information we could gather from here. And now based on this, we have to solve and get h is equal to tan alpha into tan beta upon tan alpha plus tan beta. Let's do this now. It's going to be very easy, very interesting. So first of all, we have denoted the height of the aeroplane P above the road to be h. That is what we have taken, that height to be h. Right now, and A and B are the two consecutive milestones, and if they are the consecutive milestone, then we know that AB is nothing but it is going to be 1 mile. That is what information we gathered from the given information. Right now, let's move ahead. Now we are going to consider two right angle triangles we have there. One is triangle AQP, the other one is triangle BQP. Now why we are going to consider this? Because we have two angles. One alpha belongs to one right angle triangle, beta belongs to the other right angle. And that information which we have 1 mile, right, that is the total distance of AQ and BQ. Right. So let's get into that, finding AQ and BQ, and that will help us to form an equation. Right. Let's understand how we are going to. So we consider that AQP, in that we have that acute angle alpha, right? So we say in that right angle triangle, for that alpha, for that angle PAQ, observe, what are we supposed to find? We need to find the length of that opposite side H, right? That is PQ. opposite side, and we need to get information about that AQ, which is the adjacent side. So we are talking about opposite side and adjacent side. So which ratio comes to your mind? Opposite side and adjacent side is nothing but it is tan. So we use tan of alpha. So we write tan alpha is equal to PQ upon AQ. So we write there tan alpha is equal to PQ, which is nothing but we have taken it as H. We write there H upon AQ. We don't know. Keep AQ as it is. So from this, I said we need to get the value of AQ. So from this, we can say we take that AQ onto the left hand side. Tan alpha comes to the right hand side on the denominator there. So we have AQ is equal to H upon tan alpha. Wasn't that easy? Simple, right? Same way, we follow the same thing for the next right angle triangle which we have. That is triangle BQP. Let's do that. So in that right angle triangle BQP, observe that angle beta. For that angle beta, we have that information about the opposite side, which is nothing but PQ. And we need to gather information about the adjacent side, which is nothing but BQ. So we talk about opposite side and adjacent side. So which ratio comes to your mind? Yes, it is nothing but tan. So we use tan of that angle, that is beta. So we write tan beta is equal to PQ upon BQ. Right? So we do the same thing. So tan beta remains as it is. The value of PQ we know is H, and BQ remains as it is. Right? So now we need to get the value of BQ. So from here, right, we take BQ to the left hand side, right? So we take BQ is equal to H upon tan beta, right? And now we got the value of AQ and the value of BQ. Now this is going to help us to form the equation now. Now observe very carefully. Now let's use this AQ and BQ to form the equation. So now we can see that AB, which is made up of AQ and BQ. So we can write AB is equal to AQ plus BQ. So AB remains as it. Will substitute the value. We'll do it later. The value of AQ is H upon tan alpha, and the value of BQ is nothing but H upon tan beta. So now solve it further. When you see on the right hand side, we have H common. So when we take H common, into bracket we'll have 1 upon tan alpha plus 1 upon tan beta. So when we take the LCM here, we get AB is equal to H into the bracket we'll have tan beta plus tan alpha upon tan alpha into tan beta. So now we have AB is equal to, right, the value of AB, we know the value of AB, we'll substitute it now, that is 1, is equal to H, right, and into the same bracket which we have now. It's so easy. That entire denominator what we have, tan alpha into tan beta, would go into the right hand side, left hand side now. So we'll have tan alpha into tan beta, right? And that in the numerator, from there, tan alpha plus tan beta would come into the denominator here. Right? So we'll have tan alpha plus tan beta in the denominator. And what is there on the right hand side is nothing but H. So now we got that value. So hence we have proved that we wanted the value of H to be tan alpha into tan beta upon tan alpha plus tan beta. That's the sum, a very important sum.